Welcome to the future. Technologies and innovations that sculpt our industry. This episode recorded live at the 2024 AHR Expo. Learn more at Johnson Controls at johnsoncontrols.com. All right, everyone, thank you so much for joining us today. We're hanging out at the 2024 AHR Expo, and we're spending time with Johnson Controls talking about next generation heat pumps. So the big topic that we have in our industry, besides the refrigerant transition, which is a whole nother topic that we're actually talking about with Chris Forth over in the other podcast booth, is the changes that we're seeing in heat pump technologies. So going forward, we are making a transition in our industry. I always look at it as an evolution of our industry. You know, when we look back, I like to compare it to the automotive industry. You know, it's an easy example to show. Did you guys work on your own vehicles when you were growing up? You ever? So, you know, a lot of times we had carburetors, right? 1980s, 1990s. We'd have a carburetor. You'd have a mechanical timing system. You had the fundamentals of an internal combustion engine that hadn't changed in decades. And it was relatively easy to work on, and we got comfortable working on those, and we thought that that was the norm. And then as we decided that we needed to make a transition into higher efficient internal combustion engines, we started adding things like pressure sensors, temperature sensors. We started adding controls that would use those inputs to manage outputs. And so we made this transition from an entire industry of understanding a mechanical operation of an internal combustion engine to a solid state, higher efficiency, same internal combustion engine. So we really didn't completely redesign the engine. We made some modifications to lubrication. We changed some friction. We tried to make it more efficient, but the big thing was the change in the electronics. So we went from learning how to adjust mechanical controls on an engine to understanding how these digital controls manage that engine better. So when we look at heat pump technology, we're not completely reinventing. We're doing some modifications to our internal compression engine. We may change some lubrication. We may add some vapor injection or liquid injection, but we're still working with the fundamental same construction. But what are we doing like we did in the automotive? We're transitioning to digital inputs. We're working with pressure transducers, temperature thermistors. We're using a lot of inputs to do a better job of managing the output of that system. So let's look at the entire industry, and let's look at how heat pumps are changing the way we look at the equipment that we have traditionally worked on in the past. Because there was some stigma from heat pumps when we look at all of our predecessors, just like we had stigmas with an old cast iron engine that ran on a carburetor. They weren't efficient, but they did work pretty well, and they didn't have a lot of maintenance. But a lot of our modern vehicles have much more capability to understand what's going on inside and takes away some of those troubleshooting and diagnostics. So let's just pick on the technologies that have changed in the last decade, even maybe in the last couple of years with heat pump technologies. So let's start at introducing ourselves, and then each one of us can take a shot at what you've seen individually.
Perfect. Yeah, I can introduce myself first. My name is Matt Schlegel. I'm a commercial product manager, so I specifically work with our light commercial rooftop units. Our facility manufactures from 3 tons up to 80 tons with rooftop units and commercial splits from 7.5 to 50 tons. My focus specifically is our 3 to 12.5 ton product line. I've been with Johnson Controls around 10 years, brief hiatus away, back at it. And so, yeah, 10 years with Johnson Controls on the light commercial product side. We can maybe all introduce, and then we can tackle the question.
Sounds good. Thank you. I'm Rajesh Dixit with Johnson Controls. I'm Director Global Product Management for applied heat pumps using synthetic refrigerants, but also responsible for the industrial refrigeration side of the business of Johnson Controls. So I manage our Frick, Sabro, and York brands globally. So I'm really glad to be part of this podcast here to talk about the diversity of technologies when it comes to heat pumps, as well as the refrigerants that are deployed in heat pumps.
Excellent.
Yep. So my name is Piero Caballero. I am a product manager for Johnson Controls residential part of the business. So we are the small guys in terms of capacity. We do all the way from 1.5 to 5 tons. So our factory in Wichita, we manufacture products like furnaces, air conditioners, heat pumps, obviously. We have residential packaged units. We have coils. So I specifically focus on heat pumps. So I've been brought to the team to kind of look at the next generation of heat pumps, assess what's happening in the industry, and that way we can make a product that is as efficient as it can be on the heat pump side.
Okay, well, Piero, let's start from our residential and let's work up. A lot of people here are going to be familiar with the residential side of heat pumps, probably not as familiar with industrial, but we want them to be. And so we're going to show the entire residential, commercial, industrial aspect of where we're going.
Perfect, yeah. So I think on the residential side, we've definitely seen a trend. I think two big trends. One of them, variable speed, so inverter-driven compressors are starting to become the norm. I think the proliferation of inverter-driven components is becoming just more and more out there. Obviously, the efficiency levels are becoming more stringent. Government regulations are becoming more stringent, so that's driving some of that adoption of variable speed. The other big trend that we're seeing that's related to technology is going to be cold climate.
Yes,
I think there's a need for cold climate heat pumps just because as we transition to electrification, right, and kind of moving away slowly from fossil fuels, I think the need for having a heat pump that is efficient in colder climates is definitely essential. So we're starting seeing the trend here. We're seeing that most of the industry is kind of adopting heat pumps that can operate all the way down to negative 25, negative 40
Isn't that
degrees.
amazing?
So that is kind of starting the trends. We're starting seeing those trends.
Now, one thing that I have noticed with some of the manufacturers is if we look at even, say, 2 years ago, we may have had a majority of the models that are available being single stage or two stage and a minority of that being inverter-driven systems. Have you seen a flip in that for model selection? Because as we drive closer to efficiency, we really have to introduce inverters into the mix to be able to meet these requirements. And so I'm starting to see a lot more inverters and a lot less single stage and two stage equipment.
Yeah, absolutely. There's still a market though because of the price point. There's markets that are more price sensitive. So you still need to have a single stage or a two stage, but we're seeing definitely absolutely what you're saying. The regulations are getting more strict. The efficiency levels, we need to just keep up with the industry. So yeah, absolutely. Inverter driven is kind of becoming the norm in the residential. We're still seeing in certain markets, like in the South, for example, in the US, we're seeing still the need for single stage or two stage because you optimize it at a certain temperature.
Yeah,
right?
absolutely.
So that is something that is, I'd say, the benefit and obviously the price as well of a two stage. It's less complex. So that drives down the cost of the units.
Yeah, and that completely makes sense. Now, Matt, when we think about the commercial applications, not everyone thinks about heat pumps in a commercial environment. And primarily because a lot of times we don't even see the equipment. We're talking about a lot of rooftop units. We're talking about a lot of systems that are not in the environment that we are witnessing. But there are a lot of heat pumps in the commercial sector. And what is the evolution of heat pumps now that we're going to see in the commercial side?
Yeah, so I really love the example you used with the car earlier because that's exactly what we've seen, not just with heat pumps, but with commercial products.
Yeah.
The transition from electromechanical to microprocessor controls,
Yes.
the digitalization of the entire portfolio, starting in the unit itself, how you commission it, how you service it, and now moving into the customer space and how our customers interact, how a building owner is going to interact. It's so much has become digitalized that was not before. And we've seen that same thing with heat pumps, specifically with Johnson Controls. The introduction of our smart equipment controller roughly 10 years ago really moved us into the microprocessor world from a control standpoint, where it is now our standard controller. You cannot get controls from us that are going to be electromechanical anymore.
Oh, wow. Okay.
What that's opened up with us for heat pumps is bringing in some of those other technologies. So we're not quite at the same level of technology integration with inverter compressors as the residential team.
Yeah, I get
but
that.
variable speed fans, all of that's going to be standard on all of our commercial products, whether it's an AC or a heat pump. And so that's the first kind of introduction into inverter technology for our customers was with VFDs applied on the blower, modulating your airflow there, which obviously gets you to higher efficiencies.
Indeed.
As we do look forward and where things are going, so Piero talked about cold climate heat pumps. That's definitely something in the commercial sector we're watching as well.
Oh, really?
Commercial's
Wow.
a little bit behind the residential folks as an industry.
Yeah.
One of the things I think really helped the residential side of the business is the DOE Cold Climate Challenge.
Oh, yeah. That really sparked everyone's interest.
Yeah, it sparked interest. It firmed up specifications. It kind of made funds available. Nothing like that has really come around on the commercial side yet. And so, as a product manager, specifications, that's my world. That's what I care about. And,
Sure.
And as an industry, we're kind of picking here and there, trying to figure out who's going to set that cold climate spec. Is it going to be the Department of Energy? Is it going to be CEE? Which entity is going to come forward and say, this is what a cold climate heat pump needs to look like in the commercial sector? We know as we drive to that, heat pumps are going to probably have a multi-phase evolution, like you talked about. So in the commercial world, like you said, they've not been as prominent, not been as thought about. One of the things you see as a result of that in a lot of manufacturers' portfolio is you may have 3-4 different efficiency tiers for an AC model, and then here's the heat pump as well. The
Exactly.
heat pump a lot of times was an
More like an
afterthought.
optional item. Yeah.
Exactly. You had kind of niche markets, certain climates that it played really well in. And so what we've seen is the first stage of that evolution is getting to higher efficiencies. And so we have multiple efficiency tiers. We have multiple product lines that overlap the same tonnage that all have heat pumps. So specifically our 3 to 12.5 ton portfolio, we have 3 different product lines that cross that tonnage range. Each of those now has a heat pump available. And on 2 of those, we have multiple efficiency tiers, a standard efficiency and a high efficiency.
That's interesting.
Just within the heat pump. In the past, that wasn't a thing. It was just, here's the heat pump. If you need it, I hope it fits your needs. And so there's been a lot of evolution there moving forward. And we know inverter compressors, that's going to be a big part of the future as we reach higher efficiencies and prepare for cold climate heat pump challenges as well.
Yeah, I can absolutely see that. And I can understand why there is a slight lag in between the residential and the commercial. When we look at the technology transition, we are driving for most of those transitions to happen in that residential sector first, with our commercial and our VRV following afterwards. But it's not a lot of time. So, in the next couple of years, I would anticipate we're going to see a lot more changes in that commercial sector, especially as we start becoming more comfortable in the residential side of inverters. Well, what about when we get to industrial? What are we going to see there, Rajesh?
I would start by saying that every chiller is a heat pump.
Yes.
Okay, so
Yes.
over the years, last 20, 30, 40 years, we have been using a lot of chillers. Now with the push for decarbonization and decarbonized heating and with customers having very clear carbon neutral goals and net zero goals, the most viable path to decarbonization is the use of heat pumps.
I agree.
Once again, I'll say that every chiller is a heat pump. Now, you asked about the trend. The biggest trend that we are seeing, and I can provide a global perspective, but let's start with North America. In North America, if not all, many of the legacy buildings have this 180F or 160F hot water loop.
Sure.
You have existing boiler using fossil fuels that produces that 180F water that goes into the building. It comes back at 160. And then the same building has a standalone chiller for the cooling needs of the building. So you have a standalone chiller, you have a standalone boiler.
Working on a similar system. Same environment.
Right. So now if you really want to decarbonize and cut down your CO2 emissions, I'm not saying eliminate the boilers, but try to reduce the usage of the boiler to the maximum possible extent. So you need a heat pump that can simultaneously provide chill water and hot water. Now the standalone chiller that you had in the building was doing, let's say, 42 Fahrenheit chill water.
Yes.
And the boiler was doing 180F hot water. So you need a heat pump that can do simultaneous 42F and let's say 170F hot water. There are not many technologies out there that can do that. But fortunately for us, as I said, every chiller is a heat pump. So there are places in the world like Middle East where water is a big issue. Has always been a big issue. And they need a lot of cooling.
Yes, a lot of water for these towers.
Right, so dry coolers and bank of radiators.
Yes.
So several years ago, 10, 15 years ago, we developed what is called as a high lift chiller that can provide the chill water that you need, 42 degrees or 44 degrees, using very high entering condenser water temperatures, something like 130 Fahrenheit, 140 Fahrenheit. Now look at the same equipment in a different way. If I apply the same equipment as a heat pump, now I can get 42F
Yeah.
and 150, 160, 170F. That makes the building retrofits very practical.
Sure,
And
absolutely.
you don't need to get into expensive airside conversions. So that is one big trend. If you really want to decarbonize existing legacy buildings, you got to have that medium to large capacity, high lift, high temperature heat pump. But the other one, of all the sectors and segments, if there is one that has committed itself more to sustainability, is the higher education.
Yes.
The college campuses, right?
Yes.
For obvious reasons. And on any college campus, the heating load, the 10% of the total heating load, is for low pressure steam. That is used for sterilization, cage washing, autoclaves, and so on. So our customers are now coming, okay, not only I need 170 Fahrenheit hot water, very
Sure.
high hot water temperature, but now actually I want to decarbonize my steam.
Oh, yeah. I
Okay.
hadn't really thought about it from that perspective.
So now you're looking at totally different heat pump technology that can actually deliver steam directly, replacing the fossil fuel based steam. And that's the other big one.
Okay.
If we are able to do that, then the industrial process decarbonization also gets simplified.
Yeah,
But
absolutely.
now you
it
kind
does.
of replace your 30, 40 pound steam with the steam coming from the heat pumps as opposed to from boilers.
Wow.
And our customers are expecting to do all of this using low GWP refrigerant.
Yeah,
Or in
yeah.
some
Just
cases,
add this on top.
yeah, and in some cases, customers say, actually, I want a zero GWP refrigerant. So fortunately, we are working on all of these technologies using variety of refrigerants. There is no one ideal refrigerant.
No, absolutely.
So that's why we are
A
kind
lot of transitions right now.
diversified quite well.
So I think about particularly our buildings. I hadn't even thought about the school aspect of heat pumps from the industrial side, but when we start looking at the electrification movement and we see that we're going to be eliminating gas options in many places around the country, that does provide a immediate solution when we start looking at high capacity heat pumps that can deliver both our chilled water, our hot water, and now even potentially steam, and at low GWP refrigerant solutions. So as we look at an industry, not only we're looking at the residential taking shift, we're looking at commercial taking a shift, we're looking at industrial taking a shift, and so we're hoping to paint that picture for everyone that an entire industry is actually moving, and we're learning these technologies as we go, and there's a lot to keep up with, and so that's a fantastic representation of what we will see for new equipment in an industrial application. So let's talk about time frame in some of these. Let's go back and talk about residential. And we've seen this transition into residential specifically in our air-to-air heat pumps. But what about like air-to-water? Are we seeing air-to-water solutions? Because we know that in industrial we have air-to-water solutions. Do we see residential moving into a potentially an air-to-water environment, particularly with the capacity and the capabilities of these heat pumps?
Yeah, this is a great question. I think that there is a slight trend in that direction. We're not seeing it as prevalent yet,
Especially here in the US.
In the US, yeah. I think in international markets, I think they're a little bit more popular. I think in the US, we're still very strong with the air to air. So I can't really speak. 90% of our products, or at least the products that we manage in the Wichita factory, are going to be air to air. So I think that's something that we haven't seen as much air to water, but I think there is definitely a market for it.
Right, because we look at industrial applications, it's a prime candidate for our air to water exchanges. Mm-hmm. What about in the commercial side? Do we see more heat pumps being introduced for a air to water style scenario in the commercial applications?
So they're certainly there. I would say probably the biggest hindrance of transitioning to air to water and where packaged rooftops kind of reign king is cost. And we know a majority of installations are going to be cost focused. And I think, frankly, that's something that has held heat pumps back a little bit in the past, is seeing that cost delta going from an AC with a furnace to a heat pump. Some customers, without having the education of understanding the decarbonization benefits and those things, they didn't want to pay the higher price point. So I do think as we explore air to water, it's growing as all heat pumps are growing. I think cost is going to be a big deciding factor on, can we land at the right price point? Can we get customers the air to water product at a rooftop level, or is it going to continue to be a little bit higher and drive customers to the rooftop solution?
Excellent. You know, Rajesh, you mentioned a very interesting thing with refrigerants a while ago, that everyone is looking for solutions for refrigerants. We have a lot of limited access to refrigerants in this R410A phase down, particularly. In industrial, it can sometimes be even crazier with the amount of refrigerant transitions. So I get a lot of questions about what refrigerants are we going to see with the manufacturers. And so I think it's a good opportunity to take a look at the refrigerants that are going forward, and not just in heat pumps, but in equipment in general. So let's look at the residential side, and let's understand what Johnson Controls is going to be looking at for some of our lower GWP refrigerants in equipment.
Yeah, I mean, absolutely. I think this transition, like you mentioned, right, has been very hectic for the residential market.
Absolutely.
You know, we went from 410A to 454B, slightly flammable refrigerant, so we've put all the safety around it. And I think that's kind of where we're seeing in the next few years. We expect to have another transition coming up. We don't have a timeline yet, but
No.
we definitely see it coming.
I know
right?
it's coming.
So as
We
we
have to.
make those regulations stricter around low GWP, I think that definitely our R&D teams are exploring different refrigerants like propane or CO2. There's a lot of refrigerants that are out there that we can potentially look into. So that is what our teams are doing. They're researching, they're looking at performance, they're looking at efficiency levels. How can we maximize and get the best out of our heat pumps with different refrigerants? And what is the impact to the cost? What's the impact to the material? Do we have compressor technology that's available that can support that transition? So all of those things we're looking into. We're just kind of waiting to see what the industry as a whole is doing, but we are very prepared. We're looking into all of that, just like we did with this latest transition.
So with
And
this,
if I could, I wanted to add just a little bit to that. You
Sure.
know, Piero talked about being very prepared, and I think one of the things that our engineering teams did really well. So with the transition, moving to A2Ls, low GWP, our teams really found two refrigerants they wanted to consider. R32, R454B were the two they looked at, and multiple years of testing went into the decision-making process. One of the things I really liked that our engineering team did in selecting R454B was kind of looking to the future and, okay, we've got a low GWP threshold now, 750 coming in. These two refrigerants, they're both below that. But what happens if that number drops?
what will it be in the future?
Right, what will it be? And so one of the benefits that we saw in utilizing R454B was trying to insulate ourselves if there is a slight decrease in the future to that maximum GWP that's allowed. Let's say it drops from 750 to 500.
Yeah, which
with
is
R454B, we are still below 500.
Okay.
And so R32 is above 500. And so we wanted to kind of insulate ourselves from a potential slight decrease in the future before it drops all the way to zero or whatever the case may be. And Piero mentioned something I want to talk about on the commercial side. He mentioned the safety factor as well. And that played a big role. I would say a majority of our development on the commercial side has been around the safety factors. You know, what happens not just with the refrigerant, but our electrical components. You have to look at what are they rated for? Are they, you know, spark
What's the
rated?
environment that they are in?
Right,
Yeah.
right. Our engineering team, so with refrigerant detection systems, knowing that we have to put these sensors into our units, they want to optimize. You know, we want to have the fewest sensors as possible.
Yeah.
You know, keep our costs as low as we can for our customers. And so we went through a test process where they put, I think in one case, it was over 30 sensors inside of our unit, intentionally had a leak within the unit to simulate the field environment. And they looked at where the refrigerant was pinging all these sensors.
Looking at concentration levels in different areas.
Exactly, and figuring out where
would
can
we need to
optimize
put
our
it if we
sensors.
needed to?
Yeah. So how can we put the fewest sensors in the unit to optimize and make sure we cover every piece of that unit? So I mean, in some of our commercial products, we've been able to locate just a single sensor in the product. Some, as they get bigger, need 2 or 3 sensors based around all of that testing. And the last thing I want to say, and then could turn it back to you.
No, this
question.
is great. This is a wonderful segue into another topic here.
So from a safety standpoint too, and kind of a helping our customers through the transition, you know, with commercial products, with all products, but our commercial products kind of spread across 3 different categories of how we have to treat A2L refrigerants from a safety standpoint.
Okay, sure.
Because of the amount of refrigerant in the units. So there are 3 categories. There's a threshold that if you're below 4 pounds,
Yep, M1.
code does not require a refrigerant detection sensor.
That's
It's
right.
optional, but it is not required by code. If you're in the middle threshold, where a majority of our
M2.
commercial products land, it is dependent on where that product's applied.
That's
The upper
right.
threshold, you always have to have it. It is just, hey, there's so much refrigerant in this unit, you have to have a sensor. But a majority of commercial products, basically everything that my team manufactures from 3 tons to around 50 tons, falls into the middle category where you actually have to look at not just the unit, but the application. You have to look at how much space, what's the volume of the space that unit cools or heats for a heat pump. You have to look at the smallest room that's serviced, and you even have to go down to look at like the discharge height in the space. What we have done as Johnson Controls, we want to give our customers as much flexibility as possible. We don't want to just say, look, you might need a sensor, so we're going to put it on everything. We want our customers to be able to make that decision, but know that they are making the right decision based on code. And so we've put together a calculator. We call it our RDS calculator, the Refrigerant Detection System calculator. It's available to our customers on our DS Solutions app. It's available in our selection tools. So what our customers can do when they're selecting our A2L products, they can go in, make a selection, and we know, obviously, we're the manufacturers, we know how much refrigerant is in that unit.
Absolutely.
We plug that into the calculator, and then we walk them through step by step. What is the total area that you're
Let's
servicing?
measure this location. How much cubic space do we have in here?
Exactly. So we walk them through that process, and then we make the calculations for them.
Oh, I
and
love
we
that
let
idea.
them know at the end, and they can add it to their engineering submittals, and it will say an RDS is required or an RDS is not required for this particular application. Now, again, a customer can always choose to have the sensor if they want to. If it's a large job and they know some units need it, some don't, and they want consistency. Or even if they just, hey, they want to provide that extra level of
extra
security.
piece of security.
So they can always do that, but we want to make sure they are accurately informed of whether it's required for their particular application.
I'm so glad you went this direction because I've always been hesitant to ask. I ask everyone, hey, can I see what your RDS system looks like? Can we look at sensors? Can we see what our control looks like? And I've got a lot of input on the residential side, but I've not gotten a lot on the commercial. And that's a wonderful explanation of what we're doing. We're just looking at the space going, okay, is there a potential of needing one here? And you may not. And if you don't, but you still want to add one, we still have that capability. And we have a calculator to help make that more sense.
Absolutely.
Well, if we look at that as a whole, is that a topic that we can talk a little bit more about, is RDS and different applications?
Sure.
I think it's a fantastic thing to talk about because we have so many people going, I know it's coming. I know it's going to be here. What is it going to look like? So in our commercial, we're starting to see, we got a good calculator for that. What about in the commercial or the industrial and the residential sectors? Industrial is kind of a unique one because a lot of it's outside, but there are times where we will see some interior applications.
Yeah, so, first of all, as my colleagues actually well said, we are better prepared and preparing proactively for the future. At this particular show, on our booth, Johnson Controls booth, we have 2 air-to-water heat pumps. The first heat pump is with R454B refrigerant, and the other one is transcritical CO2.
Oh, looky
Completely
there.
Natural refrigerant with a GWP of less than 1. And then we have 2 heat pumps, water-to-water heat pumps that are with low GWP refrigerants as well, R1234ZE.
Really? I
Yes.
missed that. I've got to come take a look
Yeah,
at that
definitely. And then R515B. But besides these fluids, right, as the trend is to go to higher and higher temperatures, hotter and hotter hot water temperatures, potentially creating steam out of the heat pumps, we are also investing in naturals. And so I listed down some refrigerants here so that I don't miss any.
Yeah.
And so besides the one that I already quoted, we have ammonia, which is a B2L fluid.
Yeah, absolutely it is. Don't hear much about it,
So
but it
we're doing
is
a lot
there.
of ammonia heat pumps, pentane. We are working. We are doing butane heat pump right now.
Okay.
We're working on pentane soon. Then we are also working on something unique, which is a blend of ammonia and water. We already have water as the refrigerant in our portfolio.
Absolutely, yeah.
Now we had ammonia as well. Now we are using a blend of ammonia and water. And so, and then transcritical CO2 that I already mentioned. So really a huge variety of refrigerant choices for our customers. From a safety point of view, from a plant room ventilation point of view, I've been to plant rooms with ZE and with ammonia. So they have the standard requirements like ventilation fan, the refrigerant leak detection, emergency washers. So it really depends on the refrigerant charge.
Sure.
A lot of ammonia chillers and ammonia heat pumps tend to be low charge anyway, but yet, there are some plant room requirements that you need to
To address with the
comply
two
to.
wells. Yes.
You need to address through.
Okay.
I wanted to mention something, but
Yeah.
I don't want to deviate from your agenda.
No, this
But
is an
something that
open agenda. I want this to, this is
Something-
the best conversations when they go off the rail.
Something that I forgot to mention. So, you talked about trends and insights. One of the big things that is happening out there is what is called as geo exchange, which is different from geothermal. So, in the case of geothermal, you are extracting the heat, but you're not necessarily returning the heat,
Yeah, absolutely.
the fluid. But in case of geo exchange, it's a closed loop. So let's go back to our chiller.
Yes.
And let's say we are in the month of July, hot month of July, August. So the chiller is producing chill water. And let's say typically you are using cooling tower water for the condenser.
Sure.
So that heat is being rejected to the cooling tower, right?
Right, absolutely.
So instead of rejecting the heat to the cooling tower, now you're actually sending it using a geo exchange system, let's say 700, 800 feet deep, that goes and exchanges heat with the sedimentary rocks.
Yes, absolutely.
Right? And so that becomes like
Your storage capacity. Yeah.
storage capacity. And so at that depth, the outside ambient temperature has no influence. So that becomes like your thermal storage tank right
Absolutely, it does.
there. So come winter time, you can harvest that heat, and that becomes a evaporator source
That is very
to
intriguing.
deliver 160, 170, 150, whatever the customer wants for
Sure.
heating. And a live example of that, this is not a hypothetical
Design. Yeah.
design. It is actually being done at Princeton. It has been done at Princeton. We just commissioned the system with
Really?
2 large heat pumps. Beautiful. The name of the plant is called Tiger Plant, Thermally Integrated Geo Exchange Resource System. So
I love that
what is
idea.
Princeton doing? Princeton is very clear. No combustion and no cooling towers. Simple.
Okay.
No combustion, no cooling towers. Do it all with heat pumps. And so today, this morning, there was an article from New York Times, and I just want to make sure I quote it correctly.
Sure.
So the title of the article was to slash carbon emissions, colleges are digging really deep.
There we go.
And so something to watch out for is geo exchange.
Yeah, I can see that. We talk about energy. There are a variety of ways that we can transfer energy, and we always forget that. We typically look at heat pumps going, okay, we're going to move heat from a place that we don't want it, and we're going to put it to a place that it doesn't particularly pertain to us. So we're moving heat from indoors to outdoors. Well, what about that heat? We just moved energy. Why can't we store our energy and reutilize that in other applications? So I'm really glad that you brought that up, because it makes us think outside of the box, which we're going to have to going forward. Our entire decarbonization effort, whether you look at it as a degasification or you look at it as electrification, they all are serving the same purpose. We're looking at reducing our global impact. We're looking at reducing our carbon footprint. And how do we do that? Well, we simply look at it from a new perspective. We use technology to be able to bridge these gaps with energy and put them into places that make more sense, and that makes so much sense.
And also make it easy for our customers, because heat pump is a great idea,
Yeah.
but there is also a general lack of awareness and a bit of a reluctance to
Indeed.
deploy, right? So make it easy by taking the turnkey responsibility and making sure you are able to offer, let's say, factory performance test.
Sure.
So the customer can test the heat pump at different conditions. Every customer is unique. So for example, in the case of Princeton University, we not only tested the unit at design points, but 17 other off design points to simulate the real world conditions.
Okay.
The Princeton team was there. So all I'm saying is a heat pump manufacturer should have that capacity to demonstrate the performance before the unit is shipped to the field.
I really like that idea. So even in the industrial side, a lot of times we think about what happens in the industrial can move down into commercial, can move down into residential. So now we have all 3 sectors of our industry looking at what are our best options. I look at that going, there are so many potentials in the commercial and in the residential applications if we rethink how we use our energy. Many times in the commercial, especially when we get into the VRF side of things, we look at like heat recovery, where we're starting to use our thinking outside of the box perspective going, if I have one room that needs heating and I have one room that needs cooling, why don't I just move the heat from one location to the other and not expel it to the air outdoor?
Exactly.
I can use so much less energy to do that type of work. So I hope that we see more of that going forward. Is there? I know we can't talk about R&D side of things too far, but do we look at those in the residential and commercial applications as potential energy solutions?
Yeah, absolutely. I think the residential can be a little bit more challenging because the smaller you go, right, there's losses, the percentage when you start having
It's
all those
more
thermal
fractional,
losses,
sure.
it's going to be more impactful on your system.
Yes.
I think on the residential side is a little bit more fragmented, I'd say. But yeah, definitely that's something that in the future we're definitely going to start seeing that, and we see it as, in some markets. We see where, like to your point, right, the heat that is being rejected can be used to heat the water that you use
Sure,
to shower.
why not?
So there's a lot of potentials there, but I think it's going to be we're going to follow the trend of the industrial commercial teams
Yeah.
potentially.
Can I also bring in an extra element?
Oh,
This
please do.
Decarbonization journey. So we talked about energy savings and CO2 emissions, but more and more the focus is also shifting towards water.
Yes.
You know, a lot of places water just doesn't exist or it's too expensive.
Exactly.
So somebody stopped by at our booth yesterday and made me walk him through the heat pumps and the major components. And in the end, he asked a very important question, saying that, okay, so what is the sustainability impact of this particular unit on display? It was a 400 tons cooling and 7 million BTUs of heating,
Okay.
42 and 170F. So I took an example, assuming electric rate of 10 cents a kilowatt hour, and let's say gas $1.20 per therm,
Yep.
something like that. So the quick numbers were, you will see annual energy savings in terms of OPEX cost down by 25%. Then water savings of 30%. What does that mean exactly for a 400 ton application? Actually, that means a savings of 4 million gallons of water. 4
Really?
million gallons of water. And then how much
Wow.
CO2 can you avoid?
Sure.
You can avoid something like 3 to 4,000 metric tons of CO2 per year. So carbon tax is not here yet, but it's coming.
Absolutely,
It's
it is
already
coming.
there in Canada.
Yeah.
It's there in other parts of the world. So the CO2 avoidance is not just a good to know number,
Right.
but it will have a commercial
It
impact.
could
in the
be a
times to come.
standard at some point.
Yep.
Oh, okay. Well, let's talk about this. So we know that we're making a lot of transitions here in the United States and North America. I feel like we are actually very behind times in these transitions. Can we talk about what we see in the commercial and in the residential and industrial internationally, and give us some hope that, you know, we are kind of behind. We need to catch up. We need to get to some new places in the industry. So what do we see internationally happening in the heat pump eras?
All right, thank you. So in North America, somehow the focus seems to be on buildings,
Yes.
but in Europe, I see that they are extending themselves beyond buildings. So industries, process industries are a big consumer of primary energy.
Yes, absolutely they
So
are.
once again, if you need to decarbonize that steam, you need those high temperature heat pumps, high capacity heat pumps. So there are two things happening, at least in Europe. One is industrial process decarbonization, but also district heating. So you have, for example, recent example is city of Hamburg, or we have done district heating in Paris and Vienna and such places.
Okay.
But recent example is Hamburg, where they will be using the evaporator source as the water from the harbor and putting that in the evaporator to produce hot water for the city of Hamburg.
Really?
Then in Vancouver, we are using municipal sewage water
Yes, I've heard
as
a lot
the
about
evaporator
this.
source,
Yeah.
neighborhood called Falls Creek, to deliver district heating. Then Enwave Energy Corporation in Toronto is doing district heating using heat pumps. But beyond district heating and buildings, in US at least in the last 18, 20 months, 24 months, I'm seeing really good momentum. Dallas Fort Worth Airport comes to mind. So they are going the heat pump route.
Okay.
Ford Automotive Company. They are deploying 5 heat pumps for something called as Ford Blue Oval City.
Sure.
So, yes, we have been a bit behind the rest of the world, but I think we are catching up very fast and in a very practical way. But in Europe, once again, back to the focus is on steam right now to decarbonize that steam. And
Right.
in Asia is all about, in China, for example, it's all about district heating. So,
Okay.
Yeah, and if I can add to that, I mean, I think on the residential side, uh, we've seen in the global, market, we've seen yeah, you're right. They're ahead. We're kind of behind, lagging behind with the electrification effort, decarbonization. So on the residential side, variable speed and inverter driven equipment, it has been more popular, or mini splits, for example, on the residential side have been very popular. So I just wanted to add that because that's something that yeah, I mean, we see that. So ducted systems are a little behind when it comes to those type of electrification efforts.
Indeed. Is this an opportunity to talk about heat pump water heater side of things? Is this a topic that any of you have an interest in, or save that for another topic? Because I know we start seeing heat pumps used in a variety of other applications. I just know it's an interesting thing that we see. I've seen a lot of equipment around for domestic water. We always talk about them for the comfort cooling side. Do we see much in the heat pump water side in commercial applications?
I can honestly say I have to bow out on that one.
Okay.
I'm
We'll save that one for another
ducted
topic
systems
then.
only, yeah. Exactly.
Okay. So what do we look forward to in the next couple years? What are our primary focuses for Johnson Controls looking at the education and development of heat pumps for residential, for commercial, and for applications? And what are some good resources that we will have for our contractors and for educators looking at new products, wanting to know, I need to know about these, I want to see what this product is, I need some help understanding what's going on in this sector. Let's start with residential and work our way up.
Yeah, absolutely. I think on the residential we have a lot of resources, but to everyone's points when we talked about the heat pump not being as popular or people having some maybe a bad connotation of heat pumps not being able to handle colder climates, I think that is where we're going to put a lot of our focus, trying to educate our customers and help them understand that, hey, heat pumps can do more than what you
do
think
a
they can
lot of work.
So I think that's going to be one angle that we're going to take. The other angle is obviously educate our customers about the transitions that we're having and also what are the benefits of our new products that we are launching. On the residential side, ducted residential side, we have a lot of products being launched this year with a lot of new features, with a lot of, obviously, with the new refrigerant. And so a lot of our effort is going to be around that and promoting the tools, like Matt mentioned, the refrigerant detection system tool. So a lot of those things we're going to be promoting throughout this next couple of years.
Excellent. Where are some resources that we can look at for residential products?
Yeah, so our website will definitely have a lot of resources. Johnson Controls will have a lot of resources, and then you can go depending on, we're looking commercial, residential, but yeah, our website will definitely be the landing page where you can go and find more resources.
Excellent. So what about the commercial side of things for this year?
Yeah, education is going to be massively
key.
important.
Yeah.
Just, as much as in the product manager world, we kind of wear all the hats. We were joking earlier, each of us in our individual business groups, we all are the firefighters.
Yes.
We all are the, no one else knows what to do, so can you
You get
help
the
fix
call.
this? And so education, just as important as product and technology, is going to be a very key part of what we do over the next few years. You and I were talking a little bit yesterday about our industry and how you've got a lot of excitement and a lot of energetic young people coming in, and then you've got people who've been around for a little bit who maybe they've installed a heat pump and it wasn't necessarily the right application or they didn't have the right technology at the time.
Yes.
And they've said, okay, heat pumps don't work in my area. And one of the things that we really are going to have to do is educate our customers on the heat pumps of today are not the heat pumps of 20 years ago.
No, absolutely not.
In the applicable regions for heat pumps, it is now everywhere. It is not just limited to those pockets where the climate's just right and your energy costs are just right for it to make sense. It's not about necessarily the energy costs anymore. It's about decarbonization. It is about how we impact the environment, and that is something that we can now apply globally throughout North America. Really, we have applications now and ways to get to using heat pumps everywhere and educating our customers, and that starts with our sales team, and then it moves to, on the commercial side, our distribution partners, our engineers that we call on, and it moves down to the end users and letting, some national accounts we work with know, hey, if you have decarbonization goals, here's how we can help you get there. Letting large facility owners know, like, you don't necessarily want to just do a like-for-like replacement. Just because you had a furnace today doesn't mean you have to replace it with a furnace moving forward. So those educational pieces are going to be hugely important. One of the things that I think Johnson Controls is really doing a good job of taking the lead in from an education standpoint is we have in Oklahoma City, so backtrack, our commercial products are all manufactured in Norman, Oklahoma. That's where I'm based out of.
Exactly.
And to keep it close to home, we have our Ducted Systems Academy. Our training facility is in Oklahoma City, about 15 minutes away from our plant, where we offer courses on everything. One of those is a dedicated course on heat pumps, making sure our customers who may not have worked with a heat pump before, or they may not
hands-on experience.
Yes, exactly. One of the things I love with it being so close to our facility, when people come for a training course, they get to come to the plant itself.
Oh, wow.
They get
There
to
we
walk
go.
around, see where we build the product,
I
see
like
how
that
we
course
manufacture
myself.
it. Yeah, come
love
out.
that
We would
idea.
love to have you. And then we take them to the Ducted Systems Academy. They'll get hands-on training. We have every piece of commercial product and residential equipment in the facility. So whether they're there for a residential course, a commercial course, or a blend, they will have some classroom time. They'll have hands-on time. We have heat pumps in the facility. So we have dedicated heat pump courses where someone who may be an experienced AC tech can learn what's different. How do inverter compressors work in this product?
Yes.
How do I, dial in the VFD to modulate my blower to maximize my efficiency, things like that. So really taking a step forward on the education side and investing not just in, hey, we're going to build products here, but we're also going to make this our facility where we are going to lead the way with commercial rooftops. Engineering, manufacturing, training, all really within 15 minutes of each other. And then, as Piero said, we have a lot of documentation on our websites. The biggest thing right now with the refrigerant transition is we have landing pages explaining why is this happening? What is new
Excellent. There you
refrigerant
go.
going to do? Why did we choose the refrigerant we did? What does it mean for your products moving forward?
Right, absolutely. I know, Rajesh, when we get into industrial, that's a whole nother animal. It's a little bit more specific, but what do we see for training and for awareness of our industrial heat pump products?
I agree with what Piero and Matt said. But in addition to that, our digital solutions team
Yes.
has very sophisticated tools such as the CUP software, which stands for Central Utility Plan Software.
Sure.
But in the last 1 year, we have developed a very nice, cool tool. When you go to a prospective customer and you are doing this pitch on heat pumps, and it's so important that the CFO of the customer company should understand why should I allocate my capital towards a heat pump project.
Right.
So we developed a ROI tool that plugs in,
excellent.
let's say, gas rate, electric rate, water
Sure.
rate, and okay, what's my current system versus what the heat pump will do, but in a very lucid language. How much less gas I'm going to burn as a result of the usage of the heat pump. Okay, it's electric driven technology, so my electric usage is going to go up. So how much more electricity I'm going to consume?
Sure.
What's my incremental electrical bill going to be? What's my CO2 reduction? And in the end, what's my ROI? That's all they want to know. And so we developed this very simplified tool that helps you to input the numbers very quickly and
Calculate.
almost give a output that a CFO can understand very
Wow,
easily.
I like that idea.
I'll also say one more thing. Some of the heat pump jobs out there in the field have had some issues where, unlike a chiller, right, for a heat pump to work properly, you need to have proper load balance.
Oh, absolutely.
You got to have that cooling load in order to deliver the heating.
Sure.
Right?
So-
And that's where we have had problems, where manufacturers have had problems, I should say, where you need all the cooling from the equipment, but you don't need as much heating because of maybe it's a warm day, whatever, kids are off for vacation, etc., right, on a college campus. So how do you resolve this problem? You resolve this problem by innovation. And we have something called as double bundle condenser, 2 condenser bundles within a common condenser shell, where you now get rid of that excess heat that you don't need and still keep the equipment online.
Oh, wow.
So yes,
There you go.
training is important,
Sure.
but also true innovation and building into your design all those features that help our customer. And the other thing that we have included now is the variable frequency drives.
Yes.
So heat pumps operate at different conditions, variable conditions, during daytime, during nighttime. Sometimes you may be recovering water from a river not necessarily from a building.
True.
So the temperatures fluctuate. So how do you keep the equipment online and not just rely on training? So
Okay, so a lot of things happening with our heat pump technologies. So we thank Johnson Controls for joining us today. I want everyone to stop by, take a look at all the innovations, the technologies, the transitions, our new refrigerants, and we look forward to seeing you all next time on Did You Know, the ESCO HVAC Show. Thanks, guys.